We are recording.
Okay, today we're going to be doing problem 29 from page 256. So right now I'm just going to write down the problem. The first thing we're going to do is find the first derivative. So I broke this down into 10 steps, so this will be step number 1. To find the first derivative, you're going to multiply the 4 by the 3 to get 12x, and minus 1 from the exponent will give you 3. Plus 3 times 4 is 12x again, and then minus 1 from the exponent will be 2. We're going to set that equal to 0. Now we're going to factor out a 12x squared. So we're going to get x plus 1 equals 0. Now we're going to set each of these equal to 0. So we'll get 12x squared equals 0, which will give us x equals 0. And x plus 1 equals 0 will equal x equals negative 1. Now I'm going to circle these in red because we're going to need these later. Our second step will be to find the x-intercept. What we're going to do is we're now going to factor out from the original equation. So we'll get x cubed multiplied by 3x plus 4 equals 0. Now again, we're just going to set each of these equal to 0. So x cubed equals 0 will make x equals 0, and 3x plus 4 equals 0 will be x equals negative 4/3. Now I'm going to circle these in red too, because we're going to need them later. Our third step will be to find the y-intercept. Now to find the y-intercept, you just plug 0 into the original equation. So we'll have f of 0 equals 3 times 0 to the 4th power plus 4 times 0 to the 3rd power, which will equal 0. Our fourth step would be to find the vertical asymptote and the horizontal asymptote, but because there's no denominator, we won't have one, so we'll just write no vertical asymptote or horizontal asymptote. Our fifth step would be to find the critical values, which we found earlier, and they're going to be 0 and negative 1, so we'll just write previous page. Our sixth step will be to draw a sine line. Now to draw a sine line, you're going to draw a horizontal line using your critical values on the line. So we'll have negative 1 and 0. Now negative 1 will plug back into 12x squared, and the 0 will plug into the x plus 1. So we're going to write those off to the side up here. And you're going to draw a dot where we'll plug in. Now to finish the sine line, you're going to think, what if you were to plug negative 1 equals into x plus 1, anything you'll get will be negative. So you're going to draw a dotted line. If you plug in anything above negative 1 into this problem, you'll get a positive. So you'll draw a straight line. Now if you'll go to this one, if you plug in anything below 0, you'll get a positive into this equation. And if you plug in anything higher than 0 into this equation, you're still going to get a positive. So we're going to break this down into 3 sections. You'll have a negative and a positive, which means your line will be going downward. You have a positive and a positive, which means your line will be going upward. You have another positive and a positive, which means it will be going upward. Now your seventh step is going to be finding the second derivative. So you're going to use your first derivative right here. So we'll rewrite that. And you're going to find your second derivative. So 3 times 12 is 36x, minus 1 from the exponent will be 2, plus 12 times 2 is 24x, minus 1 will be to the first power. Okay, now you're going to factor out a 12x, like we did earlier. You can get 12x times 3x plus 2 equals 0. You'll set each of these equal to 0 again. So 12x equals 0, you'll get x equals 0. 3x plus 2 equals 0, you'll get x equals negative 2/3. And I'm going to circle these in red again because you're going to need them later. Oh, and going back to the sign line, you're going to need to find an f of negative 1 where you'll plug the negative 1 back into the original equation, and you're going to get negative 1 back out. And you'll plug in f of 0 back into the original equation, and you'll get 0. Step 8 will be finding the critical values for the second derivative, which is what you found, which is 0 and negative 2/3. So we'll write previous page again. Your step number 9 is going to be finding the sign line of your second derivative. So we'll call this sign line number 2. You're going to want to draw another horizontal line, and using your critical values, you're going to write them here. So it'll be negative 2/3 and 0. And negative 2/3 is going to plug into 3x plus 2. Your 0 is going to plug into 12x. So we'll write our dots there. Now again, if you want to plug in anything below negative 2/3 into this equation, you're going to get a negative. And if you plug in anything more than 2/3, you're going to get a positive. If you're going to plug 0 into 12x, you're going to get anything below 0, you'll get a negative. If you plug in anything more than 0, you'll get a positive. We're going to break that down into 3 sections again. So we have a negative and a negative, which will be a positive. We have a negative and a positive, which will be a negative. We have a positive and a positive, which will be a positive. And now we're going to find our f of negative 2/3, which you'll plug it back into the original. And you'll get negative 16/27 and 0. So for our final step, we're going to draw our graph with all of our information. Okay. Okay, I'm going to break this down into 0.2, so we'll have 0.2, 0.4, 0.6, 0.8, 1, 1.2, those are all negatives. And then we're going to break this down to negative 0.2, 0.4, 0.6, 0.8, and 1. They're going to be negatives too. Okay. So now when we go to plug in our points, we know that our x-intercepts are going to be 0 and negative 4/3. So we're going to just draw little dots there. 4/3 is approximately negative 1.3. So we're going to draw those there. Our critical values, we'll start with our second derivative. So we have negative 2/3 and negative 16/27, which is approximately negative 0.6 and negative 0.59. So our point will be right there approximately. And using our critical values from our first derivative, we're going to have negative 1 and negative 1. So we'll draw our point here. And that's going to be your relative minimum. And our other one will be f of 0 and f of 0. So our final and last step will be to draw the line connecting all the dots. And that is how you do a curve sketch.